Okay, so we've done a lab now where we measured out the mass and volume of 5 different metals. We did lead, let's see, copper, we did zinc, aluminum, and tin. Okay, so we were able to calculate the density by taking that mass divided by the volume, D equals M over V. Now this is good for really pure samples. So if I have a piece of aluminum that is sure just aluminum, then, great. But a lot of times we deal with impure samples in chemistry, and we have to get that material from somewhere. We have to gather it, extract it, refine it. So there's also a pretty good chance that we're going to have some samples that aren't totally just that substance. So we can't expect our density to land dead on the value with just one sample. A lot of times we would need to collect a bunch of samples and measure out their mass and volume, mass and volume, mass and volume, and kind of find an average between them to kind of best fit the density of that material, like aluminum or tin or something like that. So one sample isn't going to cut it. We need kind of a bulk of samples to sort of correct for that impurity and stuff like that. So in a single class period, we don't really have time to go through 400 different samples of the same metal and continue to do mass divided by volume is density, mass divided by volume, mass divided by volume. So instead, we can use a graph that can plot a lot of data points all at once and kind of shortcut our way to the density. Okay, so we're going to do this in the Unit 1 folder. Open this up. All right, and we're going to part 2 of this density lab. So Unit 1, lab number 2, part 2. All right, and your guys' screen is probably going to look a little bit different. So on mine, I have assignment in progress submissions because I'm going to be looking at the stuff you turn in. But you should have a little tab up here that says, I think, my document or something, where you can find something that looks like this. Okay, this is a Google Sheet. It's a spreadsheet, right? And you'll be able to open up your own copy. So it'll be separate from everyone else's, and you'll be able to submit it from here too, where you'll have a blue bar at the top, and you can say, edit, and you can say submit assignment and things like that. So if you take your Google Sheet into a separate tab and you don't see Schoology around it, just when you go back to Schoology and to this assignment, make sure that all your updates are there. Make sure everything that you've kind of done is showing, and then you can submit it from Schoology that way. Okay, so let's open this up. It's going to look something like this. All right, so I've got a bunch of data over here. I've got volumes and masses, okay? Volume and mass, volume and mass, volume and mass for 5, let's see, is that right? 5, yeah, 5 different samples of the same material, and then there's 5 different materials. So I've got a lot of data here, okay? So it would be a long time for me to work it out and do mass divided by volume for all, 25 of these sets of data and trying to figure out, what best fits those. So instead, here's what we're going to do. We're going to take this data here, and we're going to make a graph out of it, a chart, okay, that's going to fit a line through all these different points, and we're going to see where that goes. Okay, so this first example should turn out to be lead. If I do the chart right, I should get a density of somewhere close to 11.34 grams per milliliter. Now, if you're watching with a close eye, you might notice my volume isn't in milliliters over here. It's in cubic centimeters, cm to the third power, cm with a little 3 there. So, does that mean I'm going to get a weird answer? It's not going to match? Well, a milliliter is actually the same volume as a cubic centimeter. We use different units for it, depending on how we calculate it. If we want to do length times width times height, for like a solid especially, we usually come from cubic centimeters, whereas milliliters is usually best fit for liquids. But 1 cubic centimeter is the same as 1 milliliter. So a gram per milliliter is going to be the same as a gram per cubic centimeter. So I can kind of interchange them as I wish, right? So First off, I need to make a graph out of all this data here in this kind of example box. So I'm going to click and drag on my volume label down to this last mass down here, this 22.68. And you don't have to grab exactly there. I can grab from this and drag down to here. I can do it from the bottom. Doesn't really matter as long as I've got these cells highlighted. I want all my data and I want the labels at the top. Okay. Once I've got that selected, I need to tell Google Sheets to make a chart out of this data, okay, out of these volumes and masses. So I'm going to go up to the Insert button right here and click that. And then I'm going to click Chart down here. Oh, I'm going to click Chart down here. Boom, Chart. And Google Sheets is going to do its best to try and make a graph for me. And this is pretty darn good. This is something that we want it to look like. We want to have dots for each of our points. We've got mass on the y-axis going vertical here. We've got volume on the x-axis going horizontal. Okay, and then I've got dots plotted. Boom, 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 boom. For every combination of mass and volume, mass and volume, mass and volume, mass and volume, and mass and volume. Okay? Now, you might look at this and say, well, we've got a bunch of data points. We're going to get different densities for all these. But you might also notice that these are in a straight line. I could draw a line pretty close through all of those. It might not be perfectly through all of them, but it's going to be pretty darn close. Okay, so that's what we're going to try and do. We're going to try and put a line through these points to see if we can get a relationship between them. Okay, so now if your graph doesn't look like this, if it looks like this, we got bars, no, that's not really going to help us. Or if you've got just a straight line like this, I mean, that's okay, but we kind of want the dots there to show where our data points are pretty clearly. All you have to do to change your chart type is to go to this chart type button, click on it, and pick the one with dots on it. And we call that a scatter chart. You can see it kind of hovering over there. Okay. If you can't find it up here in the suggested charts, you can just keep scrolling down. Oh, there it is, scatter right there. So we want a scatter chart. Okay. You can also just double check and make sure, again, volume is our x-axis, mass is our y-axis, and it should do it pretty automatically for you. Okay, so once Google Sheets kind of figures out your first graph, it's pretty good from there, but you might have to do a little bit of editing to get it to look like this the first time. Okay, once we got dots that are pretty much in a line here, we're done with the setup. So once we have our graph set up, we are going to customize it. So I'm going to click Customize over here. And if you accidentally close that tab, don't freak out. You can open it back up a couple ways. You can double-click on your chart and it comes back. You can click on it and then click on these three little dots and say Edit Chart. Like that. Either way. So if you accidentally get rid of this and you're like, oh, I can't do the customize thing, don't worry, you can get back to it pretty easily. So I'm going to go to Customize. All right, and then what I want to customize is this series button right here. Okay, series is kind of another word for a set of data, like your y-axis and stuff like that. So I'm going to click series here. Okay, and you can change all kinds of stuff in this. I could change the color if I wanted. I'm going to live my best life and go with purple. Okay, I could even change what shape the points are. So instead of doing circles, I could do diamonds. Or maybe I'm just feeling like being a star today. I'm going to be a star. I'm just going to go with diamonds. Okay, so that's fine. But what I really need here is a line to go through these points. We call that a trend line. So I'm going to check that off. We call it a trend line because it shows the trend, the pattern between these dots. Okay, even if our data isn't in a perfect line, okay, it'll do its best to fit to that. So we might also call it a best fit line. Okay, so I've got this line here going through my points. Scroll down a little bit more. So now I've got more options to go with my trend line. Again, you can change the color and how thick the line is and stuff. But what I really want is for Google Sheets to tell me something about this line. And this is going to be kind of the most important part of all this. So if my goal is to figure out the density of this metal to make sure it's lead, okay, or in the other cases like sample 1 through 4, I want to figure out what the metal is, period. Okay, I need to figure out a way to calculate the mass divided by the volume for kind of all these points at once in kind of one stroke. So if I think about it, the slope of this line is going to be the rise over the run. It's the y over the x. Okay, and that's how it is in math and everywhere else. So slope is rise over run. Well, in this case, my rise is the mass, and my run is the volume. So if I do rise over run, that's mass over volume, and mass over volume is density. Okay, so if I can get the slope of this line here, that will get me the density of this metal. Okay, best fit to all these points. Okay, so I can get Google Sheets to tell me the equation of the line, and then therefore I can also get it to tell me the slope, which is going to be the density in grams per cubic centimeter, okay, or grams per milliliter, either way. Okay, so once you have your trend line checked off, you go down to label, click that. I'm going to say use equation. Bam, it pops it up right there. And then there's a whole bunch of junk in this that I don't need. Let's see. So it's 11.3 star x plus negative 2.84 e negative 15. Ugh, okay. Well, if you know your point slope form, you got the y equals mx plus b thing. Okay, the m in front of the mx is what we need, and the rest of it's kind of extra. So like this would be the b, it's our y-intercept. It just tells us that we're not going exactly through 0, we're a little bit above. So I can ignore this part. Okay, the x is if I wanted to plug in a volume value to figure out what the mass would be. All right, so again, I don't really need that. All I need for the slope is this 11.3 right here. Okay, that 11.3 is saying for every 11.3 grams I have, I go 1 cubic centimeter. Okay, so like 11.3 and then 1 cubic centimeter, and there's even a dot right there. Okay, so this is the slope of my line. Therefore, that is the density. And if I double check, hey, 11.3, 11.34, that's pretty darn close to lead. Again, maybe it's not perfect, but it's pretty darn close. Okay, so I just confirmed that this is my graph of the density of lead. I can double click on this title. Kind of click near the front, and I'm going to write in lead so I don't forget it. I'm going to do it all caps. So that way it's really out there. Lead. Okay, so I got lead as my graph here. Okay, and I can go do this for the other metals too. So now I can move this graph out of the way. And we'll go through one more example together. All right, so let's do sample 1, okay, which we don't know what the metal is. We're going to have to try and figure it out. So I'm going to click and drag to select all my volumes and masses for this sample 1. I'm going to make a chart out of this. So I'm going to go up to Insert. I'm going to click Chart. Whoops. Insert Chart. All right, and again, I get something like this with the dots. And once you get one graph done, usually Google Sheets kind of figured it out. But again, if it's not dots, you get bars or lines or a pie chart or something, just go up to chart type and make sure you find scatter either here or down here. There we go. Okay, from there, my setup is done. I just need to customize my chart. So I'm going to go to Customize. I'm going to go to Series, scroll down. I'm going to click on Trend Line to put a line through all my points. Okay, and then I want Google Sheets to tell me the slope of that line. If I just scroll down a little bit farther, I've got Label. I'm going to change that from None to Use Equation. It'll tell me the equation of the line. Bam! All right, and the slope of that line, that number before the x, that is going to be my density. That's my mass over my volume, my rise over my run. Okay, so in this case, the density of this metal is about 8.96 grams per cubic centimeter, or grams per milliliter. So what metal has a density of about 8.96? Scroll over here. Oh, well, there it is right there, copper. Copper has a density of about 8.96 grams per milliliter. So this is a graph of the density of copper. Again, I'm going to double click on my title, call it copper, and I've got another one done. So there's a freebie for you. And we've still got 3 more graphs left to do, but once you get rocking and rolling this, it goes pretty fast. Okay. When you're done, make sure you have all your graphs on here and make sure they all have the name of the metal in the title. Okay. And then again, on your version of Schoology, there will be kind of a blue section up top above your little spreadsheet, and there should be a submit assignment button up there that you can click to submit it to me.